Okay, so for this video, we'll be discussing a few more examples that is about the composite function, but they are focused more on domain and range for the composite function. Okay, so maybe you can recall back some small knowledge or maybe some small concept here before we try example 24 and the next example. Okay, when we are having the composite function fg, right? When we are drawing the arrow diagram, the g function will go first, right or not? So I'm having two circles here. So the first function that goes first will be the g, and then followed by f. And I think I did show you earlier, right, in the previous video, where the first circle here is actually the domain of g. If you have a look purely only for the g function, right? So this is actually a domain of g. And this second circle here, this second set here will be actually the range of g. And at the same time, if you are looking for the function f, this second circle is actually the domain of f. And the last circle here will be the range of f. Okay, so indirectly you can see very clearly that we are having the same set of values for the range of g and also the domain of f. Alright, and when we want to use this concept to solve the questions that's related to domain and range for this composite function, then usually we'll use this result where the range of g should be equals to the domain of f. Okay, so this is something that we need to know actually, okay, to use it and to answer some questions that's related to the domain and range for the composite function. So the same thing happen if let's say I'm having g composite f, right? Okay, so that means we are having the function f goes first, and then we followed by function g. And therefore, this is actually the domain of f, the range of f. And this is domain of g and the range of g. So again, to use this concept to answer the question that is related to the composite function with domain and range, right? So we will see this result again. So these two set, okay, so the range of function and the domain of the g, the range of f are having the same set. Therefore, we are using the formula where the range of f equals to the domain of g, okay, to answer the question usually. Okay, so basically these are two important results that we need to know. Okay, when they're trying to ask some question about the composite function and they are related to the domain and range here. Alright, okay, so usually how the question will be asking, you can have a look for example 24. Okay, if you have a look for example 24, right? So they are saying that we are having function fx where 2x plus 3 is equals to, for x greater equals to 0. And then we have also the function g for x smaller equals to q, where a, b, and q are constants. So the function fg, so this is a composite function fg, is such that they already give us the composite function fg, which is 6x squared minus 21 for x smaller equals to q. Okay, so for the first part of the question, find the values of a and also b. So to find the values of a and b, we maybe can start with the composite function given first. Alright, since we already know that the composite function given will be f gx equals to 6x squared minus 21. And I already know my function fx. So this is my function fx here. Okay, and this is my function gx. Now I want to substitute the function gx into the fx. So to substitute, I'm having ax squared plus b. This is my gx, right? Equals to 6x squared minus 21. Okay, and then now function f is something like this. And now I want to replace all the x here by using ax squared plus b. Therefore, if I continue further, I'm having 2 and then ax squared plus b. I replace x by using ax squared plus b and then plus 3. Okay, that equals to 6x squared minus 21. Okay, and now I try to expand it and try to compare left hand and also the right hand side. Okay, so when I expand everything here, right, I want to compare left and right hand side. So again, I'm looking for the coefficient of x squared compared with the right hand side, the coefficient of x squared. Okay, so you can see that 2ax squared equals to 6x squared. Therefore, if you compare them directly, your 2a should be equals to 6, where the a is equals to 3. So this is how we get the value for a. So you do the same thing for b. Okay, we try to compare the constant. Okay, so we try to compare the constant. So the constant is 2b plus 3. The whole thing here is a number. Okay, 2b is a constant plus 3 is also a constant. So 2b plus 3 equals to the constant, negative 21. So you just compare directly. 2b plus 3 equals to negative 21. You're having negative 24. And then b equals to negative 12. Right, so this is how we actually get the answer for A and also B. Okay, and this is what we have for part 1. And now let's have a look for part number 2. Okay, so for part number 2, they want us to find the greatest possible value of Q. Okay, so the question is asking for Q. And we need to know actually where is the Q actually. So you can see that when you try to observe the question here, the Q actually appears in the domain of Gx and also appear in the domain of fgx. Okay, so to solve the question that's related to composite function, fgx is a composite function, right? And then the Q is actually the domain of the composite function or the domain of Gx. Basically, you need to use the concept that we mentioned just now. Okay, so let's have a look for fgx. We'll be looking for this diagram. Okay, so for this diagram, right, the important result for composite function is we need to know the range of G equals to the domain of F. Alright, so where is the range of G? So the range of G basically is the formula that we are having for the G. So this is the range of G. And then what's the domain of F? The domain of F will be greater equals to 0. This is the domain of F. If I want to let the range of G equals to the domain of F, then it will look something like this. Okay, so the range of G is ax squared plus b, right? So just now I find out the value for a, which is 3, and then x squared plus b, which is negative 12. Okay, and the domain of f is actually greater equals to 0. Therefore, I let the range of G greater equals to 0. I didn't write out the x because x is for domain, right? Okay, so now range of G is 3x squared minus 12 equals to the domain, which is greater equals to 0. So I'm having 3x squared minus 12 greater equals to 0. And then I need to further solving this inequality, quadratic inequality. If I simplify the 3, I'm having x squared minus 4 greater equals to 0. And then when I try to factorize it, I'm having x minus 2 and also x plus 2 greater equals to 0. When we try to solve this quadratic inequality, right, there are many methods that you can use. You can use number line, you can use the table of sign if you want, or you can just sketch the diagram. Alright, whether you're having a U shape or N shape, and then you determine. I'm looking for greater equals to 0. That means I'm looking for positive. So if I'm looking for positive, this one will be the positive part, this one will be the negative part, and this will be the positive part. So by right, according to this quadratic inequality, there are two parts for my answer, where it should be x smaller equals to negative 2 and also x greater equals to 2. Okay, and now how can I decide the final answer for the value of Q? Okay, so to decide the value of Q, it is actually the domain for Gx or domain for fgx, right? Okay, so let's have a look. X smaller equals to Q. Our domain is x smaller equals to Q. Okay, so what we need to do is we have to compare x smaller equals to Q with the answer, with the value of x that we get. So by right, you should compare it with x smaller equals to negative 2, right? You cannot compare it with x greater equals to 2 because the signs are different. Okay, so we have to make sure that x smaller equals to Q, we compare it with x smaller equals to negative 2. Therefore, from here, you know that the value of Q should be equals to negative 2. Okay, so this is how we actually solve this kind of question, right? Because it is actually a question that's related to the domain or range that involve the composite function. All right, therefore you can see that this is one of the important concepts that we need to know. All right, so that we can use it to answer the question for this part. All right. Okay, so this is what we have for question number 2, part number 2. Okay, then we proceed to part number 3. Okay, for part number 3, now they are saying that the Q is equals to negative 3. So find the range of FG. Okay, again, we need to recall back what is the function FG here. So the FG is given in the question, right? Where it should be 6x squared minus 21. And they are looking for the domain x smaller equals to negative 3. Okay, so how can I decide the domain for this question? Oh, sorry, how can I decide the range for this question? They're asking for the range, right? Okay, again, usually for me, when I want to decide the range, I would try to imagine the graph. Okay, the quadratic curve in my mind first. So I'm having 6x minus 0 squared minus 21, which means that your stationary point or the vertex of this curve will be at 0, x equals to 0, and y equals to negative 21. So by right, your graph should look something like this. It should be a U shape, right? Okay, by using all the information that we learned earlier, or the concept that we learned earlier, right? Okay, we try to sketch out the diagram in a simple way, and then this is negative 21. Okay, and for our domain given in this question, they are looking for x smaller equals to negative 3. So we want to know where is actually x, what's the value when you are having a negative 3. So maybe you want to know what is actually the value that I have for the curve. Okay, because we are interested for this part of the graph only, right? Okay, so to decide the value for y, what we do is like we substitute 3 into my function f of gx. So I'm having 6, then 3 squared minus 21. Okay, so from here I'll get the value 33. Which means that this value is actually a 33. And if we are looking for the graph that's smaller than x, x is smaller equals to negative 3, that means we are considering this part of the graph. So if we want to consider this part of the graph, and we can decide the range from this graph, so you can see that the lowest value or the lowest point for this curve is actually 33. And then the graph will keep on going up, right? When x is smaller, becomes smaller and smaller. Right, so this part, it will be actually your range for the composite function fg. And therefore, you can write out very easily, the range of fg should be equals to y greater equals to 33. So basically, I decide this from the diagram, or maybe from a sketch for the quadratic curve. Okay, and we need to try imagine what do we have, okay, how the graph look like, and then which is a part of the graph that I want to consider, so that you can find out the range from the diagram. Alright, so this is how we solve example 24. Yeah, so again, what we want to emphasize on this example is you need to understand and remember the formula here. When you're having a composite function fg, the range of g equals to domain of f. And then when you're having the composite function gf, then you should have the range of f equals to the domain of g. Alright, okay, so maybe you can try another example that's related to this one also. Let's have a look for example 25. Okay, so first of all, they want us to express this in this pattern where it is a completed square form, right? Okay, so we have applied and learned this many times already, so I hope that you're able to complete the square. Right, so to complete square, I will take out the 2. I'm having plus something square minus something square. So the something here should be a negative 3 and also the negative 3 here. Okay, then the plus 11, I will just keep it outside because it will not be affected when I complete the square. After that, I will combine the first 3 terms into a big bracket with a square outside, and I'm having negative 9 plus 11. Therefore, if I multiply the 2 into the brackets and also the number, right? Okay, so this is what I have, and further simplify it, my completed square form will be something like this. So this one shouldn't be something very hard to you because we have learned it already in chapter 1. Okay, so this is what we have for our part 1. And part number 2, now they are saying that the function f, okay, is defined by this one. And then the x is smaller equals to k. And after that, the function g is defined by this one for x smaller equals to p. Okay, so this is what we have. And then you need to actually aware that the function fx given here, right, is the expression shown in part 1. Okay, so that means very likely later I need to use the result for completed square to put it into the function fx later lah. Right, very likely we need to do that. Okay, so let's have a look for. So we already skip the part 2 and part 3. We focus on part number 4. Okay, so for part number 4, now they are saying that k taking the value 1. So k become the value 1. Find the largest value of the constant p, which allows the composite function to be formed. So they want to form the composite function fg. What is the value of p? So again, we need to know where's the p. So the p is actually here, right? It is actually the domain for the function g. So again, this is a question that involves composite function and also the domain, right? So after that, find the expression for fgx whenever this composite function exists. Okay, so again, to decide the value of p, we need to find out the formula that we want to use first. So we are having the composite function fg. So again, if I go back to the question just now, to the discussion just now, right? For composite function fg, the important result will be range of g equals to domain of f. Okay, so let me go back. Range of g equals to the domain of f, right? Okay, so range of g equals to the domain of f. Alright, so what is the range of g? The range of g is this one, x plus 3. This is actually the range of g. And what's the domain of f? So the domain of f will be x smaller equals to 1. Okay, it is given that the k is value 1, right? Okay, then how can I combine these two together to decide the p? Okay, so the range of g is x plus 3 equals to the domain of f. You put it as smaller equals to 1. Therefore, your x is smaller equals to negative 2. Okay, and then to decide the answer and the value for p, right, you try to compare x smaller equals to p with x smaller equals to negative 2. So what's the value for p here? Very obvious, the value of p should be equals to negative 2. So this is how we actually solve the question. Okay, again, we still involve the concept of domain and range for the composite function, where for the composite function fg, the result should be the range of g equals to the domain of f. So when you let range of g equals to domain of f, right, the final answer that you get is the x, where it is related to the domain actually. Right, so you can directly compare with the domain x smaller equals to p, and from here you get p equals to negative 2. Then after that, they want us to find an expression for fgx. Okay, so to find the composite function fgx, again, substitute g into the function f. So what is my function g? X plus 3. And then what's my function f? So you can substitute it. You can substitute x plus 3. You can replace the x by using x plus 3. So either is like this, x plus 3 square, then minus 12x plus 3 plus 11. Okay, so you can see very clearly that you substitute the value x plus 3, the function x plus 3 into the function f. Okay, and then of course you need to further expand it, expand the square, expand everything, and try to simplify your answer. So if you didn't do any careless mistake, your final answer should be 2x squared minus 7. Okay, and then this is one way now. Then we have another way. You can solve it by using another way. So some students will say that, oh, just now I already find out the completed square form, right? For the quadratic expression here, can I substitute the gx into this function fx or not? Also can. Alright, so now maybe I will show it here also. Okay, so I want to substitute gx into the function f. So my g is x plus 3. Okay, and I want to replace x plus 3 into the x here. This is f, right? Function f, right? Okay, so if I replace it, then what do I have here is I'm having 2. Then the x become x plus 3. And then you copy the minus 3 and then square, then minus 7. Then you can see very easily that, oh, you already get the answer in a shorter way, which is 2x squared minus 7. So either one of these methods can be used, alright, when you want to solve for this composite function. Okay, but if you can look at it further, basically this is easier. Alright, the step is easier and more straightforward. Alright, okay, so these are all the examples that we have, which is about the composite function. Alright, so especially you need to take note on the concept about the domain and range for the composite function. Alright, and we will stop our discussion here. For the next video, we will be discussing the concept of inverse function.